So this is the very first video for college algebra. It's on a section called Polynomial Division, the Remainder Theorem, and the Factor Theorem. We're really just going to look at polynomial division here because that's the very most important part of the section because we're going to use it in the next section. So let's start with looking at division of just numbers that we're pretty familiar with from elementary school. So let's say we wanted to do 33 divided by 5. Well, those are two pieces, right? And they had names. This thing we were dividing is called the dividend. This thing we were dividing by is called the divisor. Okay, now whenever we very first learned to divide, and we didn't look at decimal points or anything like that, what we ended up with was an answer in two parts sometimes. So 33 divided by 5, well, we know that 5 can go into 33 6 whole times. But there's a little bit left over. So we called that the remainder. And there are 3 left over, right? So we had two parts of our answer. The number of whole times that 5 can go into 33, that's called the quotient, and the bit that's left over, that's called the remainder. And the erector set is in the way. All right, so we're going to end up with the same ideas here in polynomial division as we did in regular number division. We're going to have a dividend that we're going to be dividing. We're going to have a divisor that we're going to be dividing by, but these are both going to be polynomials. And in the end, we're going to end up with a quotient that will be a polynomial and a remainder that will also be a polynomial. All right, now we do have several types of division. We would typically in class learn about long division, which works the same way as long division with numbers. But since we do have kind of a unique situation, we're just going to look at the method called synthetic division. Now, synthetic division isn't useful all the time, but it'll be useful for our purposes in our class. So let's look at an example. I'll take you through the steps of synthetic division with this example, and then we will do a couple more. So if you're following along in the notes, we're going to do the first example in polynomial long division just as an example of how to do synthetic division. Then we'll skip down to the second page. All right, so our first example, we're going to divide 5x squared plus 9x minus 6 by x plus 2. All right, so we would call this still the dividend and this still the divisor. With synthetic division, we're going to have a specific setup that's almost as important as the process. I'd say it's as important as the process. So you really want to get the setup right. So what we do with the setup is we've got a little box here. And in the box, we're going to put the opposite of the number in the divisor. So the divisor here has an x plus 2. So we're going to put a minus 2 in the box. And then off to the side, we're going to put the coefficients of the dividend, or the coefficient of the thing we're dividing by. But we need to make sure none of the terms are missing because all of the terms from start to finish, all of the coefficients from start to finish have to be accounted for. So let's look. We have x squared, we have x to the first, and x to the 0. So there's nothing missing. We go 2, 1, 0. So everything's accounted for. So we're going to write those coefficients, 5, 9, and minus 6 off to the side. Skip a line in your notes and draw a horizontal line. And the first coefficient comes down to the bottom. Now we haven't really done synthetic division yet. All this was just set up. But luckily the synthetic division steps are really quick. So let's go through those steps. We're going to take the number we wrote and we're going to multiply it by the number in the box. All right, that'll be negative 10. And what you do with negative 10 is you write it under the next coefficient. And now we're going to add to get negative 1. Repeat what you just did, but now using the negative 1. So we're going to multiply by the number in the box. Negative 2 times negative 1 is 2. And we're going to add. Negative 6 plus 2 is negative 4. Okay, so that was not so bad. Right? Take the last number we wrote down, multiply it by the number in the box, add it to the next coefficient. Now what we need to talk about is what this represents in terms of an answer. So first, this number out here is always the remainder. So our remainder polynomial here is -4. It's always going to be your last number. This looks a little weird to us. This is not something we ever get, I don't think, whenever we're dividing actual numbers. We never get a negative remainder. It's fine with polynomials though. Now, to look at our quotient polynomial, we're going to use these two numbers. So those numbers are going to be the coefficients of our quotient polynomial, and our quotient polynomial is going to have a degree 1 less than the dividend. So our dividend here had degree 2. Our quotient polynomial is going to have degree 1, meaning it'll have this format: something x plus something. That's what degree 1 polynomials look like. These are the numbers that fill in those blanks. So our quotient polynomial is going to look like 5x plus -1. In other words, our quotient polynomial is 5x minus 1. There's our quotient, there's our remainder. And that's how we do synthetic division. All right, let's look at a couple more examples. And these will be the ones, just skip on down if you're following along with the notes, skip on down to the second page, and this is where the synthetic division starts. Okay, so here's our next one. 2x to the 4th plus 7x cubed plus x minus 12. And we're going to divide that by x minus 3. Have x plus 3. Let's do x plus 3 instead. Okay, so we're going to do this by synthetic division. Here's our dividend. Here's our divisor. Setup's the same as it was before. The opposite of this number in the dividend goes in the little box. And then the coefficients of the divisor goes in the little box. The coefficients of the dividend will be written out to the side. Now, just like we did before, we have to check and make sure that all of our terms are accounted for here. So we have 4th, 3rd, 1 degree, and constant. We're missing the 2nd degree term. That's fine. You just have to know that you have to put it in somewhere. So if ever a term is missing, all that means is that there is a 0 in front of it. So just put in a plus 0x squared so you don't forget to list it as one of your coefficients. So let's list our coefficients. We have 2, 7. Don't forget the 0 for the x squared. 1, -12. Skip a line, draw a horizontal line, bring the first number down. And we're all set up. We're ready to go with the synthetic division. Okay, now we're going to take the last number we wrote down, multiply it by the number in the box. In this case, we get -6. Add to get 1. And do it again. Multiply by the number in the box to get -3. Add to get -3. Multiply by the number in the box to get 9. Add to get 10. Multiply by the number in the box to get -30. Add to get -42. Now we have to use these numbers to come up with our answer. The easy part is the remainder. It's always the last number in line. The quotient is going to be made up of a polynomial with these coefficients on them. So the way we find the quotient is we look at our dividend and we want to knock 1 power off of that. So this has degree 4. Our quotient is going to be degree 3 with these coefficients. So it's going to have the form of something x cubed plus something x squared plus something x plus something. These are the somethings that fill in the blank. So we get 2x cubed plus 1x squared plus -3x plus 10. And we usually want to just kind of clean that up to a -3x. And if you'd like to leave this 1 off of the x squared, you're perfectly welcome to. You can just call it x squared. So we could call this 2x cubed plus x squared minus 3x plus 10. There it is. Okay, let's look at one more of these just to practice synthetic division. Okay, so let's look at x cubed minus 3x plus 10 divided by x minus 2. Okay, setup is the same. Take the opposite of what's in the divisor, put it in the box. In this case, we had a minus 2, so 2 goes in the box. Now we list our coefficients of our dividend off to the side. We see again here, though, that the x squared term is missing. Now, that's not always the case, but I wrote both of these problems, and I'm not very good at randomizing, so I left it off of both of them, but it could be anything. So if any term is missing, just don't forget to put it in with a 0 in front of it. So if we list these coefficients, that's going to be a 1, a 0, a minus 3, and a 10. Skip a line, draw your horizontal line, first number comes down. And now we do the synthetic division steps, what's called the algorithm, the set of steps that gets us to our answer. Take the last number you wrote down, multiply it by the number in the box to get 2, add to get 2. Do it again. Multiply by the number in the box to get 4, add to get 1. One more time, multiply by the number in the box to get 2, add to get 12. Right away, we have our remainder. And we're going to use these coefficients to get our quotient. Remember, the quotient is 1 degree less than your dividend. So our dividend here is degree 3, so our quotient is going to be degree 2. These are the numbers that fill in the blank. So we have 1x squared plus 2x plus 1. All right, we can leave this one off if we want to. So if you want to just call it x squared plus 2x plus 1, that also works just fine.